Okay, so we are very close to Nata exams right now. So Nata 2025 is now on. So over here, we think coming up with a marathon sessions for your preparations for the Nata 2025. So today we will be including non-verbal reasoning, ARC awareness, as well as numerical ability. And after my session, I will be taking for the first half hour non-verbal reasoning. And after that, ARC awareness section will be taken by Nishitha ma'am. She will be taking from there onwards. And at the end, numerical ability by Deependra sir. Okay. So at the end, Deependra sir will be taking numerical ability. Okay. So over here, we will be directly getting into those questions first. So which of the following options complete the pattern? Okay, so we need to take one piece from all these four options and we need to place it where, on this place of that question mark. So continuity is very much important over here. Okay, continuity of the lines. We need to look for the continuity of the lines. You guys can put your responses in the chat. Okay, I'm keenly waiting for your responses. You can put it in the chat itself. So we can connect them. Okay. I'll be using, let's try to use exact same color. Okay. So I'm just completing that figure. Okay, I'm trying myself to complete that. Okay, I know that you guys got your answers in mind. For the proof only, I'm just doing this exercise. Okay, so next one line over here. Next one line over here. Okay, so I think now everything is being clear. What we had included is this much portion. Okay, that you could find in option A. So you guys can put your response in the chat because these things will be act like a mock test. So Saurav Gupta has been given it right. Very good, Saurav. So select 3 figures out of the following 5 figures. Which when fitted to each other would form a square. So this question is from the area shape formation. Okay, this question is from the area shape formation. So there is a tip. You guys can put your response in the chat, obviously. So there is a tip to solve these questions. Identify the demand of the question. The question is to create a square. So your first task is to create that square. Okay, that is your first task. So in your rough sheet, create that square. Then look for the most repeated number over here. 1 has been repeated 3 times. 2 has been repeated 3 times. Okay, so frequently repeating numbers are 1 and 2. See, I'm just placing that 1 over here because I don't have any clear idea, but I am just going for a random picking. It won't sense good. Okay, so I'm not randomly not picking anything. I'm looking for the most repeated one and I'm just thinking about its possibility. Okay. So over here, if most repeated one is not a possibility, then I can choose the option which is remaining. So over here, I just placed the first one. So, and I can place the second one also here easily. Okay, so 1 and 2 has been easily placed. 1 and 2 is easily placed. So I can find 5 and I can take that 5 and fix it over here. So 1, 2, 5. So option B is the right answer. Okay. So option B is the right answer. So now we can move on to the next question. So this question is happened into the previous year Nata exams for the projection starter or the types of view charter. Okay. So view from the direction of arrow is being used here. So we have a technique to solve this. See, we can just looking into that and we can find the answer. One more technique is there, that is counting method, with which will help you to eliminate options. So view from this direction. How many surfaces you can see? 1, 2, 3. Two L type surfaces you can see. Okay, so total 3 surfaces. So option D, you can find that 4 surfaces are visible. Option B, 4 surfaces are visible. So we don't need to bother about that 2 options. Now comes A and B. So just look for these L shapes. Okay, option C. Now 1, 2, 3. Okay, there are 3 L shapes. Yeah, over here also you can find the third L shape. Okay, but in the option A, one is rectangle. That rectangle is not there in the direction. Okay, in our viewing direction, there is no rectangle. So you can easily eliminate option A also. So you can finalize that option C is the right answer. Okay. So next, another question we can solve over here. How many interlocking rectangular prisms are there? Okay. How many interlocking rectangular prisms? So annotated copies for this particular one. Okay, Saurabh, I just see your previous answers. Okay, it only delivered right now. So very good, Saurabh. Both were right. Good. So over here, how many interlocking rectangular prisms are there in the given image? Okay, so you can view from the direction to direction. See, 2 from the top, the same 2 will be from the bottom. So 2 from the right, the same on the left. 2 from the front, the same on the right, rear. So 2 plus 2 plus 2, 6 only. Okay. Yeah, Saurabh, good. Okay, 6 only. 6 is the right answer. Now we can move on to the next figure. How many triangles can you see in the figure given below? I will take you to the common error, which usually students I just found making. We will discuss that common error also. See, these kinds of sessions are to give an idea about the common error, tips, tricks, and all those things. Okay. So I think now we can solve this question. You guys can put your response in the chat. So before that, I will give you some basic ideas or basic figures for the understanding. Because with those basic figures, you can avoid counting. Okay. So we can save a lot of time, which we are wasting for counting. So annotated copies of this PDF, you can contact in the number provided in the chat. Okay. For exam-related queries also, you can submit over there. So few more lines. See, this is the type 1. Okay. Type 1 is having only 1, 2 triangles in it. This is type 2 square. So it is having 8 triangles in it. That is an important point. This is the type 1, only having 2 triangles. And this is the type 2. It is having 8 triangles. So this is the type 3. So this is the type 3. It is having 12 triangles in it. So if we have a previous idea, so we shouldn't need to count. Okay. We can move on to the next one. Saurabh, I see your answer. I have something to take to your attention. Okay. So over here, this is 12. Sorry, this is 16. Okay. So this is the 4th type and it is 16. So without counting, we can find the 16. Okay. And common error. This students usually miss. Students usually miss these 2 triangles while counting. Okay. This is the common error. Okay. So I will count it. So first of all, this much area 16, 17, 18, 19, 20. Now we can look into that 2 component triangles. Okay. 2 component triangle is triangle formed like this. So you can call this as the 21st one. You can call this as the 22nd one. And this one will be your 23rd one. Up to here, everything is fine. Few more 2 component triangles that we usually forget. This is the one among them. 25. Sorry. 24. We just entered at 23 only. 24. 25. Okay. So next. $26. 27. Finally, this is 28. So the right answer is 28. Okay. So we can move on to the next question. So these types of questions are very common. Okay. So be careful about these things. So next, we will be looking into this figure. I think one among the figure were wrong at that time. Okay, so question number 100 was there in that question paper. So from the questions of a cube are shown in below, which number one will be on the face opposed to the face, which is opposed to number one is asked in this question. So opposite of number one. Okay, see, what is the probable options you will be having? 1, 2, 3, 4, 5, 6. These are the possible options. So 1 will be having an adjacent side with 6. So 6 cannot be opposite to 1. So it is having an adjacent side with the 2. 2 also cannot be adjacent. Similarly, over here, 3 also cannot be adjacent. Okay. 5 also cannot be adjacent. Okay. See, we just easily removed the options. Okay. See, this is the elimination method. Okay. This is the elimination method. So we don't want that much cubes. With only 2 cubes, we solved it. So 4 is the opposite. Okay. Because, see, we can't see the opposite when 1 is present. So how many numbers you can see? Delete them from the options. See, that is a technique. Okay. See, there is no need to imagine anything. You can find my previous sessions in this YouTube channel regarding dices. Okay. There is all techniques regarding dices we have mentioned. Okay. So we don't need to imagine anything. There are plenty of students think they will imagine dice. They will just rotate it in the mind. Even they will use their hands to rotate in the exam hall. They use their hand and they will rotate their hands, and all those things happens inside an exam hall. See, all those things are not necessary for dices. Okay. Because we have techniques, tips, tricks. Use it. Okay. So be a smart worker. So now coming over here, the arrow of the given series can be combined without changing their direction to form a meaningful image. Okay, we need to form a meaningful image. So how will you form that meaningful image? You can have a look. Just look on the all the arrows. When we see an arrow, what will coming into our mind? Arrow means direction. Okay, so this is north, south, south, east. North, south, north, east. South, south, east, west. Okay. Sorry. Okay. West. Oh my God. This is east and this is west. I'll put it over here. North, south, east, west. Okay. Northeast is coming over here. And now we can look for the directions. So this is obviously west. Anyway, east or west, it's not a matter. North, south, east, west. This is the only option which is resembling this figure. Okay. So over here, we can go for option D. So now we can solve this question. The closed figure loses its side and then open figure gains its sides as the series proceeds. Okay. So the outer one is losing one side. That means the outer one is having 6 sides. Okay, it's a hexagon. So next time it is losing one side and one side become open. So 5 lines, 4 lines, 3 lines. Yeah, fine, good. Next it is 2, 3, 4, 5. Yeah, good. Option 1 satisfying the requirement. See, actually the outer one is gaining 2 sides. Option 2 is wrong. Outer one lost one. That exactly same. Option 3 is also wrong. Okay. Now comes to the final one. Okay. Now comes the final one. So over here also, the outside. See, actually it is losing only 1. Okay. So it is also not losses its sides. Closed figure losses its sides and open figure gains its sides. But from here to here, there is no loss. Option A was right. Very good, very good. Parth, Harshit, both were right. Very good, great. So now we will be solving this question. For the given font, how many alphabets can be divided as equal parts along both vertical and horizontal axis? Okay, both electrical and, sorry, both vertical and horizontal axis. So that means vertically symmetric and horizontally symmetric letters are asked here. Okay, so only few letters. You guys can put those letters also in the chat. Okay, number as well as letters I am expecting in the chat. So first of all, look for vertical symmetric, then for horizontal. Okay, so the intersection is asked. So if you, for example, English alphabet C, it is not vertically symmetric. So it will be reflected something like this. But English alphabet A is vertically symmetric, so it will reflect exactly like A. Okay. So see, here the reflections are not asked. Okay. Here the reflections are not asked. So similarly for horizontal symmetricity, English alphabet A is not horizontally symmetric, but English alphabet C is horizontally symmetric. So it will be reflected exactly same. So this is an added knowledge. Horizontal symmetric letters in mirror on bottom reflect exactly same. Vertically symmetric letters on mirror on right side reflects exactly same. Okay. So this is just a basic idea you can use to solve mirror image and water image questions involving letters. See, we don't have time to waste at the exam hall. So quickly we will be solving questions. Okay. So quickly we'll be solving. So now you guys can solve this question like I'll be directly going into the answer. Okay. Yeah. Scattered answers. Oh, there. Yeah. Yes. O is right. Okay. Saurav given O. Saurav is provided I also. Okay. I. Yes. Okay. H is there. Okay. And X is there. Only 4. Okay. Yeah. Parth given it all together. Yeah. Good. So I think Saurav, Parth, as well as Harshit, we have done it well. Okay. 4 letters. 4 letters and Parth given option C. Yeah, good. Yeah, Saurav, 4 letters, 4 letters. Okay. See, actually it is 4. Yeah, 20 trends. See it is. So 4 letters. So just keep it in these things in mind. See this particular letter. This is vertically symmetric. This is horizontally symmetric. Okay. So symmetricity of letters should find no issue. Symmetricity of these letters are very much important. Okay. Because in mirror image as well as water image, these things will be helping you to solve the questions very quickly. Okay. So over here, front. So front view of a given object is being given. So you need to identify it among the options. So when you look from this direction, see the common error in this area, this portion, how will you see from the front? Okay. See, that is a rectangle actually. So when you project it outside, it will be something like this, not a triangle. Students usually think that that piece is a triangle, but actually not. That is a common error. I'm here to address the common here. Okay, common error. I wish to address every common errors, because if you are having an idea about the common errors, we will not be fall into that. Okay. Even though if you go for a blind plus, we will avoid the option B. Okay. That is the advantage. Okay. Now comes, just look for this line. See, that line is important, but it is missing. Option A gone. Okay. Look for other lines which is missing over here. Any crucial lines? Only one line. Okay. See, actually, this particular line is missing in option D. That makes C. Okay. So over here it's Harshit, Saurabh, Harshit, Parth. Very good, great. That's it, that's it. So now another top view you need to find. Identify the correct top view for the given 3D. See, all these are Nata previous, okay? All these are Nata previous. So we can use a counting method for eliminating options. Not all we can eliminate, but we can eliminate few. Okay. So 1, 2, 3, 4, 5. If we are in a mood to guess the answer, we can use this elimination method. Okay. So intelligent guesses you can make. Yeah, good. I can see your answers. Very good. Okay, everyone, great. See, go for sides. 1, 2, 3, 4, 5. Maybe right. 1, 2, 3, 4. Obviously wrong. 1, 2, 3, 4. Obviously wrong. 1, 2, 3, 4, 5. So even if you go for a guess, it should be between A and C. Even if it is a guessing, then also it should be between A and C. Okay, never go for B or D. Okay, because it is not an intelligent guessing. Because through the counting, you can eliminate it. Now just look for the shape of the objects from the top. See, actually this particular numbered 2, that crucial shape is not in option C. So it is A. So it's Parth, Saurabh, Harshit, trendy trends. Okay. Everyone given right. Harshit, very good. Sorry. View from the direction of arrow. See, actually in a question paper for the architecture, plenty of questions you can expect from the chapter this of projection. Okay. Actually, this is an easy chapter, but you can expect a plenty of questions. And please note this. If you lose an easy question, okay, if you lose an easy question, then it will adversely affect your rank through that. It is adversely affecting your score. Okay, but if you are making wrong for a difficult question, it won't make that much harm as like the easy one. Clear? I hope you got the idea. See, you guys can put the response in the chat. Okay. So over here, view from the front is being asked. Yeah, good. Okay. See, actually there is a block not addressed. So we don't want it. Even you can go for counting also. Okay. That block is being addressed. What kind of block it is? It's not possible. Okay. So actually it is not perfect. Okay. So you can find it like option D. Very good. Harshit, Saurav, Path. Yeah, Harshit. Very good. Okay. Saurav, Path. All good. Okay. Another of surfaces in the 3D object. Okay. They will ask 2D as well as 3D objects. So now you guys can go for a count. Count it quickly. See, I will tell you that many students I found making it wrong. Yeah, earlier in my sessions, I found many of the students making it wrong. Why I am mentioning this? See, through that you need to understand that there is something to trick them. Okay, you may be tricked or not, but there is something to trick them. Obviously, it is there. So when I tell you that these questions, I find certain questions, I will not be commenting the same for all the questions, but in certain question, I will comment like that because I found students gone for wrong answers. That is why I comment like that. Now we can count it. See, this 1 It's a very huge surface. Two very huge surface. What students usually do that, they count 1 here, 2 here, they accidentally count 3 here. Okay. So next. 3, 4, 5, 6, 7, 8, 9, 10. Here one under this. That is 11. Okay. Here one, 12. So this 12 you can retrace it to here. 12, okay. And you can retrace that 8 to here. You can retrace that 10 to here. That 9 to here. We can see the 9. And even 3 to here. Okay. 7 to here. All those things are fine. Now those were not visible earlier. We counted up to 12. Okay. 13, 14, 15. 15 surface. Okay. Okay. Actually, Christian, I didn't get you that question. 1 March question. Actually, I didn't understand the question. Okay. Harshit, I think you guys understand what I mentioned at the beginning. Okay. There is a possibility of going it wrong. So right answer was option B. Saurabh, Swati were given right. Saurabh and Swati only given right. Okay. See, that is I told you. See, these kinds of questions are having a usual double counting issue. Okay, that is the issue. A double counting issue is there. So now we will be looking into this question. So this is also from that particular chapter. And there is an important concept under this. See, there is a surface under this. And that surfaces are shown through dotted lines. This is the concept. Okay, this is a concept we should keep in mind. Okay. Okay. Harshit, it is actually 15. Yeah. Okay. So now coming over here, now you can easily find that 1, 2, 3, 4 is hidden here, 5, 6 surfaces. You can see it only in option A. Okay. Harshit, you can have a look once again over here. It is 15. Okay. Because only these 3 were we didn't count it earlier. See, all the surface I had included. You can tell me near a number, sir. Near the 12, you didn't count that one or this one. Likewise. Okay. So over here, option A is the right answer. So now this question. In the given figure, if all the circles are joined by horizontal and vertical lines at the center. Okay. See, why this question were gone wrong? Students, construct the figure like this. I'm talking about the common errors. Okay. 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 So over here, this is the common error which students make because they didn't read that question even well. If all the circles are joined by horizontal and vertical lines at the center, so centers are important. Okay, centers are important. So I just redraw that figure outside. See, actually, we don't want any technique to solve this question, but I will get you a technique if the question is going complex. So with that technique, I will be handing over to Nishitha ma'am. So over here, this is like column 1, column 2, row 1, row 2, row 3. So over here, this is a 2 into 3 mesh. Okay, this is a 2 into 3 mesh. See, you can easily count and solve it like 8. So I'll get you a technique. So there is a countdown method. There's a shortcut. There's a countdown method. Okay, the method is called countdown. So countdown means just write the number of columns and rows like this and find the least number or the smallest number. It is 2. Okay, this is the smallest number. Put induce equal to the smallest number. So 2 induce. Then count down. 2, 1, 3, 2. 2 into 3, 6. 1 into 2, 2. So total 8. See where it is useful when a question comes like squares. Okay. Assume I'm drawing squares. See, actually, I'm just roughly drawn it. So whenever figures like this comes and a question, how many squares are here? So this is column 1, column 2, column 3. Assume everyone is square over here. My drawing errors are obviously there. Row 1, row 2, row 3, row 4. Okay. I'm looking for the number of squares in this figure. Now we can use a technique, countdown method. So how many rows or how many columns? 3 columns. How many rows? 4 columns. What is the smallest number? What is the smallest number? 3 is the smallest number. So put induce equal to 3. 1, 2, 3. Now you can use the countdown method like rocket launching. 3, 2, 1. Again with the 4. 3, 2. So over here, 3 into 4, 12. 2 into 3, 6. 1 into 2, 2. So over here, 20 squares will be there altogether. Okay, 20 squares will be here altogether in this figure. See, similar figure counting methods also there in my previous sessions. You can find it in this channel. Parth, very good. You can use this countdown method. Okay. See, these kinds of techniques are making toppers. Okay. So those smart workers are becoming toppers. Okay, please keep it in mind. So what kind of questions was asked in MCQ, I think. Okay. So in MCQ questions, the questions like for the Nata, in the Nata perspective, you will be getting questions from non-verbal reasoning, ARC awareness, as well as quantitative aptitude, and even like some sort of GK questions also you can expect. So in non-verbal reasoning perspective, there will be questions from figure counting, number of parallelogram. Okay, I was talking about that Christiana's doubt. So number of like figure counting, types of views, and like question from mirror image, water image, etc. has been asked. Number of parallelogram. Assume this is a parallelogram. Okay, so there is 9 parallelograms in this figure. Okay, so this is column 1, this is column 2, this is row 1, this is row 2. Okay, the technique is like this: sum of columns, this is number of parallelograms as well as number of rectangles also working on this. Okay, sum of columns into sum of rows. So what is the number of columns here? 2. So sum of columns means sum up to 2. Okay, sum of row means sum up to 2. What is sum up to 2? 1 plus 2. Sum up to 3 means 1 plus 2 plus 3. Okay, so this is 1 plus 2. So 1 plus 2, 3. 3 into 3, okay, 9. So this is the technique for parallelogram. Others we can see it later. Okay, very good, very good. Okay, Harshit, thank you. So I'm handing over to Nishitha ma'am. Ma'am, I'm stopped sharing. Okay, ma'am, you can join from here, ma'am.
Yeah, sure. Thank you so much.
Yeah, welcome.
Okay. Hello, good evening, everyone. I am here to take a session on arch awareness. You already know me well. I am architect Nishitha Joshi. I take architecture awareness sessions where we discuss various important topics related to our portion of J Paper 2 and Nata. I've brought a very interesting topic and curated some points for today's live session, keeping in mind the latest pattern of Nata 2025 exams. And the topic that we will be discussing in today's class is famous buildings of the world, famous buildings or famous monuments that you can see. So many questions are there in exam every year that are related to some or the other famous building and monument, and most of my students always ask me how to prepare for this topic, because there are so many famous monuments, how to learn about each and every monument, or how to remember every building. So in this session, I'll be discussing some famous monuments, some famous projects of master architects, and I'll also be giving you some tips on how you can prepare for this particular topic. So let's move ahead with this topic, that is famous buildings of the world. So in this, I've brought some examples of famous Indian buildings and famous buildings from different countries as well, that you can prepare for your upcoming NATA exam. So first famous monument that I want to discuss with you is Asian Games Village. This is one such site. I won't say it is a single building, but it's an entire site about which the questions have been asked many a times. You can see image of some portion of the Asian Games Village on your screen on the left side. You can see it. The Asian Games Village is a sports complex and one of its first, like one of the first of its kind in India. And this particular Asian Games Village, this complex, this athlete village was designed by famous master architect from India, that is Raj Rewal, in 1982 to host the Asian Games, which were supposed to be held for the first time in India, or any such big sporting event for the first time in India. That makes this particular sports complex first of its kind and very important. That is why so many questions are asked on this topic every year as well. It is built on the Siri Fort area. Siri Fort was a historic Khilji era fort in Delhi. So on the ruins of that forts, like some portion of that area, this Asian Games village has been designed, and architect's name is Raj Rewal. So whenever you are studying about any famous building or monument, please look at the images of that monument, because in NATA, a lot of image-based questions are also there, where you have to identify a certain monument or part of that structure or building material or some important aspect about the monument just by looking at the image. So you should be able to identify the famous building or site by the images. So look at the images carefully. Read about the building material that has been used in designing a particular monument, and also learn about the famous architect who has designed that building. Next one is Palace of Assembly. Palace of Assembly is actually a part of Capitol Complex in Chandigarh. And as you already know that Chandigarh, the entire city, has been planned by the world-renowned architect and town planner Lee Corbusier. So you can see an image of the Palace of Assembly on the left side on top. You can see the image of this design by pioneer architect Lee Corbusier. So it is one of the monuments inside the Capitol Complex in Chandigarh city that was designed as part of Chandigarh city plan by Lee Corbusier. He was an architect who used the modern style of architecture to design his buildings. And you can see so many elements of modern style of architecture in this building as well. Especially the exposed concrete building that he has created. The Legislative Assembly, Secretariat, and High Court are all part of the Capitol complex, along with the open hand monument inside the same complex, which signifies the idea behind designing the city of Chandigarh. Uh, this particular building has a circular assembly chamber. Please look at the image of this assembly chamber. Previously, question has been asked by just showing the image of that chamber, and the question was to identify the monument. Next famous building is Lotus Temple. Last year in 2024, we had a question regarding Lotus Temple that asked about the cladding material present in the shell roof of Lotus Temple. If you know the answer to this question, please let me know in the comments of this video. What is that material that has been used for cladding of the spins that you can see on the roof of Lotus Temple that makes it look like a lotus? The answer is actually very simple, so I hope all of you will be able to respond. The famous monument was designed by a rather slightly unknown architect Faribur Saba, who designed and constructed the Lotus Temple. It was designed in 1986 and it is a Baha'i house of worship. So previously this question has also been asked that which religion is Lotus Temple related to? So it is a Baha'i house of worship where people from all religions are welcome, and it is a place where they try to promote noise-free worship, meditative worship, and they urge you to not make any sound inside the complex. And this building not only looks like a lotus from the elevation point of view, but it also looks like a lotus from, if you look at it in the plan, if you look at the top view of this building, it will look like a lotus that is sitting on 8 ponds. Small ponds are there below each and every leaf of this flower that looks like a lotus. So it looks like a lotus that is sitting on a water body. The next famous building complex is Bharat Bhavan. Bharat Bhavan is a creation of a very famous Indian architect called Charles Correa. It is a very exemplary building complex made in brick. The government of Madhya Pradesh created and sponsored Bharat Bhavan, an autonomous multi-art complex and museum in Bhopal, which is the capital city of Madhya Pradesh. Charles Correa was the designer of Bharat Bhavan. It contains various art galleries, a graphic printing factory, a ceramics workshop, an open air amphitheater, a studio theater, an auditorium, and a tribal art and culture museum. So you can see some images of Bharat Bhavan on the left side. It was founded in 1982 and it is right in front of the Upper Lake, which is a very famous and very large lake in Bhopal city. So it is right in front of the lake, facing the lake, and it is a prominent art, culture, and literature center where multiple activities can take place at the same time. If you look at the image, first image carefully, you will notice that the building does not have a very large height. It is only constructed on the ground floor, and some spaces in the building are also in the basement level or mid ground floor or lower ground floor level, and there are some open spaces like the amphitheater and open galleries as well that makes this space very unique. Another famous building made in brick, just like Bharat Bhavan Bhopal, is the Embassy of Belgium. Belgium's diplomatic representation of to India is housed in the Belgian Embassy in New Delhi. This building was designed by architect Satish Gujral, and along with Belgium, this also houses the embassies of Sri Lanka, Bangladesh, Maldives, Bhutan, and Nepal. Next famous structure is Brooklyn Bridge. Brooklyn Bridge is present in Brooklyn in America. It is a very famous bridge that you must have seen in so many shows and movies because it is a very popular site and very popularly captured structure. The Brooklyn Bridge spans the East River between Manhattan Island and Brooklyn, and it was one of the longest suspension bridges of the world at the time of its opening. The bridge was previously known as New York and Brooklyn Bridge, and later it was just renamed Brooklyn Bridge. It was constructed in the early 21st century, and it was designed by John A. Roebling. Next famous structure is the Tube House. Tube House is actually a very tiny house. You can look at the image here on the right side bottom. This was a very remarkable building structure, I would rather say, because it was one of the entries in a design competition, and this particular tube house won the first prize. And the competition was about low cost housing, how to create housing that is affordable for all strata of the society. So Ahmedabad's Tube Home took first place in an all India competition for low cost housing. These are row homes, meaning this is a series of homes, and they have high density, and without sacrificing any living room space, they have created tiny and affordable structures. Next famous monument or famous building is Burj Khalifa. Burj Khalifa, as you all know, is the tallest structure currently in the world. Prior to its inauguration in 2010, the Burj Dubai was known as Burj Khalifa. It is a skyscraper in Dubai, UAE. It is designed by a team headed by designer Adrian Smith, and it is the tallest skyscraper with a height of 829.8 meters. Next famous place is Connaught Place. Connaught Place is a large area which was formerly known as Rajiv Chowk, present in New Delhi. It is a British era marketplace, you can say marketplace or commercial district that was designed, keeping in mind another similar kind of commercial district in London. So it was a replica of the original design from a place in London. It has many white colored buildings, which are colonial era structures, and there are many similar kind of buildings in the same area, which house many brand stores, restaurants, pubs, and offices of many important organizations in India. It also has the head office of LIC and many such remarkable offices in this area only. Connaught Place, CP, Rajiv Chowk, all are names of the same area only. So if any of these words come in the exam, please don't get confused. And this entire place was designed by Robert Tor Russell, who was a British designer. Next famous building is Petronas Towers, also known as Petronas Twin Towers. As you can see very clearly in the image that these are twin towers or two similar towers which are adjacent to each other. And one of the most remarkable things about these towers is that they are connected to each other only at two places. First, at the ground floor, the only connection where you can go from one building to another. One is at the ground floor, and the other one is at the 40th floor, using this bridge that you can see. So it was a very marvelous design when it was first created in 1998. Petronas Towers are twin buildings present in Kuala Lumpur in Malaysia, that stand 170 meters above the ground. The structure, which held the title of world's highest building between 1998 to 2004, and it is a symbol of the capital city of Kuala Lumpur in Malaysia. Many famous personalities related to architecture and construction were associated to the design and building of this particular structure. Famous architect Cesar Pillai was also a part of the designing team, and along with him, many other prominent personalities were there behind the successful construction of this Petronas Twin Towers. Next famous structure is Eiffel Tower. Almost every year or every other year, there is a question about Eiffel Tower in Nata exam. The most basic question being, what is the material used to construct Eiffel Tower? So as you can see, it is a metal structure made with wrought iron. It is present in Paris, France, which is known as one of the most famous tourist attractions of the world. It was named after the engineer who constructed it, who was Gustave Eiffel. So from his name, this structure got the name Eiffel Tower. It was earlier not very celebrated when it was first constructed, because there were other buildings in France which were much more ornamented and beautiful. But as this building, as this structure received a lot of recognition through popular culture in movies and shows, then it became a very famous tourist attraction and global icon for France and its tourism. Next famous building structure is Hiranandani Garden. Hiranandani Garden, or simply Hiranandani, is an upmarket township in Powai in Mumbai. This actually, the entire locality has penthouses, condos, bungalows, and commercial complexes. Hiranandani was built by the Hiranandani Group and is accessible from north and south part of Bombay, and is a very prominent housing and commercial district in Mumbai. Jawaharlal Nehru Stadium. So as you can see, I've brought a variety of structures, not just buildings or historical monuments, but I've brought bridges, towers, stadiums, and all sorts of structures to give you an idea of what kind of questions or what kind of structures can be asked about in the exam. So you cannot expect only one type of building or historical monuments to be there. The questions can be related to comparatively newer famous structures as well. So Jawaharlal Nehru Stadium is present in New Delhi, and it is an all-seated stadium which can house 60,454 capacity of people at once. And it was constructed keeping in mind the standards of international organizations like FIFA, AFC, and IOC to host various type of sporting events. Next one is High Court Building of New Delhi. It was constructed in 1966, the High Court Building, founded by some prominent figures from the judiciary background in India. You can see the design of High Court Building. It looks like a rather simple structure as compared to all the other ones that we have studied, but it is one of the earliest judicial buildings that was designed after independence. So it is very prominent for Indian architecture. The next one is Kanchenjunga Apartments, another very famous building about which multiple times there have been questions in Nata exam. Kanchenjunga Apartments were also designed by famous Indian architect Charles Correa. So as you can see, Charles Correa, Raj Rewal, Achyut Kanvinde, these are some of the famous personalities of Indian architecture, famous architects from Indian history, whose projects have been considered as marvels. And the questions related to these particular architects and their projects, they are asked repetitively in the exam. So please make sure that you prepare well for these particular architects and their projects. So Kanchenjunga apartment is a luxury apartment building which has just 32 apartments, which are all double-storied apartments, and it is uh, and it is a part of an upmarket society in Mumbai. And this building is actually very unique because although it is a very luxury, fancy apartment building, it is also very well planned and a sustainable structure. It is designed so well, keeping in mind the sun path and climatic conditions of the city, that it is even today considered as one of the best designed buildings and is considered as an example of apartment building design in India. Next famous building is LIC building. As I was telling you that this head office of LIC is also present in Connaught Place. So this is the same building that I was talking about. It is also designed by famous Indian architect Charles Correa, and it was designed in 1986. LIC building LIC building is the sole landmark in Connaught Place that provides a sense of direction. It is present almost at the center of Connaught Place, and it has a glass facade and space frame construction. The outside walls are covered with Agra sandstone. So you can see that a mix of traditional and new age materials have been used to design and construct this building by Charles Correa. Next one is Parliament House. The Indian Parliament House, housed in the Central Vista, the Sansad Marg of New Delhi. Central Vista has been in a lot of news for the last 3-4 years because of the Central Vista redevelopment project, which is being done by HCP Design, led by Bimal Patel, who is an architect from Ahmedabad, currently very famous architect from India. So you should remember all these names: HCP Design, Bimal Patel, Central Vista Redevelopment Project, because questions can be asked on the basis of these recent famous projects as well that are being held. So, but right now I'm talking about the old Parliament building, which was designed by famous British architects Sir Edwin Lutyens and Sir Herbert Baker, along with the new capital of India, that was New Delhi. It is present only 750 meters away from Rashtrapati Bhavan, and it had a circular plan. And if you know, it was designed keeping in mind the Chaucer Yogini temple, which was a historic temple from India. It also has a circular plan. So keeping that temple in mind, this parliament building was also designed. Next one is Rashtrapati Bhavan. A very interesting question about Rashtrapati Bhavan was asked in last year's JEE paper 2, that the dome of Rashtrapati Bhavan is inspired from which famous Indian monument? And the answer to that is Sanchi Stoop. If you look closely at the design of Sanchi Stoop and the design of the dome of Rashtrapati Bhavan, they are actually very similar. So this dome has been inspired from there, and Rashtrapati Bhavan was also designed by Sir Edwin Lutyens and Sir Herbert Baker. Rashtrapati Bhavan is currently the presidential palace. Formerly, it was Viceroy's house and subsequently government house. It is present in Rajpath. As you already know, this is the place from where the parade and flag hoisting ceremony starts on 15th August and 26 January. So it is a very important building for India. Please study more about Rashtrapati Bhavan, Parliament House, and Central Vista, as these are some prominent landmarks from British architecture in India. Along with these two buildings, India Gate is also very close by. On one end of the Central Vista, Parliament Building and Rashtrapati Bhavan are there, and on the other end of Central Vista, India Gate is housed. Next famous structure that I want to discuss about is World Trade Center. You already know that this is the World Trade Center, the twin towers of USA, which were attacked in by terrorists in 2001. These were one of the highest skyscrapers at one point in the world. The first World Trade Center was a huge complex of 7 skyscrapers in New York City. And they were demolished in 2001, September 11th, because of the attacks. Now, a new World Trade Center has been designed. The World Trade Center was a symbol of New York City during its time. It had a significant part in popular culture with 472 films depicting it, according to a certain estimate. So it was there in pop culture, and the movies and shows made it very popular. I would also like to tell you about the upcoming Nata and JE2 crash batches that we are launching right after the end of board exams, starting from 24th, 26th, and 31st of March. So if you are looking forward to learn all of these topics that I take in Arch Awareness in detail, you should join for these upcoming batches so that we can discuss about such topics like famous buildings in great detail, and also clear your doubts related to such topics and discuss more questions that are that can be seen in previous years exams as well. So just like these, there are many other famous buildings. I'll take you quickly through some more of them. After that, I can hand over to the next faculty who will be taking your drawing session. So some more famous buildings are there, like the Chrysler Building, which is also present in US, which was one of the highest buildings when it was constructed for the Chrysler Corporation, which was an organization or a company which was US based. Another famous building, which is very common in questions of NATA and JE paper 2, is Sydney Opera House. So it has a very similar kind of roof design like Lotus Temple, which is present in New Delhi. Both of them actually have shell roofs, but the material of construction is different from both. I had asked a question about cladding material for Lotus Temple a few minutes ago, and I asked you all to answer in the comments. The right answer is marble. Marble tiles are actually used for cladding of Lotus Temple. Similarly, the Sydney Opera House also has shell roof, and this represents the principle of design of movement because of its design. Burj Al Arab, another famous tall structure or skyscraper from Dubai. It is actually a 7-star hotel. In fact, the first 7-star hotel of the world, and it was designed by the famous British architect Tom Wright. The bucket building, which looks like a basket, a picnic basket, it became very famous and got a lot of limelight because of its unique design, and it was actually designed for a company known as Longberger Company, who designed baskets, who manufactured baskets. Next one is the UFO house, also very famous for its unique design. The Coliseum in Rome, the Leaning Tower of Pisa, Golden Gate Bridge in California, the St. Peter's Basilica in Vatican City, Pyramids of Giza, Notre Dame in France, Sagrada Family, a famous cathedral designed by Antoni Gaudí in Spain, the Great Wall of China, which is one of the 7 wonders of the world, the Arc de Triomphe present in Paris, the Willis Tower in Chicago, Acropolis, which was a town in Greece. Acropolis is also the place where the famous Greek temple of Parthenon is located. Then the St. Mark's Basilica, the Louvre Pyramid and Louvre Museum present in France, Times Square in New York, White House in Washington, D.C. These are some of the other famous buildings and monuments that you can read about. There is a long list of these monuments, students, and we can discuss all of this in great detail when we have more detailed classes. But this is it from my side today. But from this session, I'm sure that you have already gotten an idea on how to prepare prepare all the famous buildings, because there are so many of them. I'm sure it becomes a great task for you all to remember and memorize all of them. But if you prepare for these buildings in this manner, keeping in mind the tips that I've shared with you, I'm sure the preparation will become easier. Now I'll be handing over to Deependra sir, who will be taking your next session. Thank you all for your patience.
Thank you so much, Nishitha ma'am. I hope you all must have enjoyed this wonderful session and you all must have learned a lot of things from this session. So now we'll be discussing a lot of things about the aptitude part. So I'm just sharing my screen. You can give me a confirmation in the chat box whether the screen and my voice, everything is properly visible to you or not, and things are running smoothly or not. So I hope the screen which I have shared along with my voice is functioning properly and you all can hear this and see this clearly. So let's get started, students. I would request that whenever I show these questions to you on the screen, you also start solving them simultaneously. And as soon as you get the answers, do write your answers in the chat box. Good evening, Harshit. Good evening, everyone. So all the queries, concerns you have, you can write those directly in the chat box. I'd love to respond to those. With that, let's get started. It's a mixture of questions from the aptitude part. Thank you so much for the response, Jatin. With that, let's proceed further. So the question number 1 for the day says that the HCF and LCM of two numbers is 11 and 7700 respectively. Good evening, everyone. Now, what it says is if one of the numbers is 275, find the other number. Please understand, there is a property which is true for two numbers. So if there are two numbers, you can always state that, let's say first of the numbers is n1, second number is n2, then their product is always going to be equal to the product of their LCM and HCF. Always remember this as a standard formula, which is true for two numbers. I repeat, this is true for two numbers only. So whenever you're having two numbers, their product is always equal to the product of their LCM and HCF. Which means if I have LCM as 11 and HCF, other vice versa, HCF as 11 and LCM as 7700, which means the product of these two numbers will be equal to the product of their LCM and HCF, out of which one of the numbers is 275. So shall I say the second number which I'm looking for is going to be N2. Now I think this is one of the easiest tasks. Harshit, this clearly is not a hard question. This is a very easy question. So if you know the basics, if you know these basic concepts, you can crack them quite easily. So from here, I think the remaining part of this question can be done by all of you quite easily, because all you need to do is divide 11 into 7700 by 275, which you all are able to, and that's how you can find the value of N2. So I hope the question was easy, the concept was understandable, and you all could understand it quite easily. Again, I'll show you another question for the day, and I would hope that some of you would answer this. That's brilliant, Saurabh, and I would request everyone to take a note of it, that LCM into HCF is always equal to product of those two numbers. Now, let's have a look at this next question for the day. It may look a little confusing. It may look a little disturbing. Okay, Jatin Patel, that's brilliant. I'm glad you answered the question. But let's talk about this question now. This question may look a little difficult one, but this really is a simple one. If you just observe it closely, if you still haven't, let me take you through some other identity. There is an identity, students. Are you aware of this identity that, A cube plus B cube can always be written as A plus B whole times A square minus AB plus B square. Similarly, there is one more identity which goes like this, that A cube minus B cube can be written as C. How I remember it? See, it is going to be A, B, A square, AB and B square. But the signature, the signs confuse everyone. So what I do here is I remember it like this, that this is the plus sign. So this sign remains same, which means if there is a negative sign here, I'll have a negative sign here, which means if it was A cube plus B cube, there was A plus B. And if it is A cube minus B cube, there will be A minus B. Now always remember, A square and B square will always remain positive. They are always positive. This is just a technique which I follow, to remember this formula. You can also follow this. That's good. Dilbasha asks, that's brilliant. That's a good answer. But now let's focus on this question. So what it says now is that, see, A square and B square will still remain positive, but this sign was positive here, so this sign became negative. So here I'll say that this sign becomes opposite of what was there. I repeat, this sign becomes opposite of what was already there. So if it was a negative sign here, it will be a positive sign here with this AB. So I hope you all must have been able to understand this formula, this concept. With that, if I just ask you to assume 2.333 as A and 1.667 as B, do you not think that the question now looks like A? So 3 times A, which means A cube, B, 3 times B, which means B cube in the numerator, divided by A into A, that's A square, A into B, that's AB, and B into B, that's B square. So I hope most of you must have been able to understand that this question is really not a difficult one if you know the basics. What I do next is the numerator A cube plus B cube can be written as, I hope you all can see it very clearly, A plus B times whole of A square minus AB plus B square whole divided by the same factor A square minus AB plus B square. Now what I do next is I'll divide this part by this part. So finally, I'm left with A plus B. Now, I hope you all are realizing how simple this question is. So the question now is 2.333 plus 1.667. So I hope if you know the basics, you can crack such questions quite easily. This is how easy this question was. So I hope you all must have been able to answer this question. That's brilliant part. The answer is going to be 4. So I hope you know the basics. If you know the basics, if you know these formulae, if you know these identities, you can crack these questions quite easily. Let's introduce the next question for the day if you have understood this previous concept. Here is the next question for the day, students, and I'll be really glad if some of you could answer this question in the chat box. So try to write, try to solve, and then write your answer in the chat box. I'll be really happy. How I would approach this question, let's have a look at that. There is an equation given to us which says x square plus 4y square, is equal to 4xy. And what are they asking? They're asking you the value of x is to y. Now, how do we do that? How do we do that? Please understand, it's again a very simple question. What I do here is I am dividing both the sides by y square. I repeat, I am dividing both the sides by y square. So when I do that, it becomes x square by y square. It becomes 4y square by y square, which eventually helps you in cancelling the y square by y square. And here you have 4x by y square. Now, what I do next is, I hope you all can see it very clearly. X square by y square can be written as square of x upon y, whole of x upon y, plus here this y square gets cancelled by this square. So this means this is going to be 4. And here this y cancels one of the y's, which means you're left with 4 times x upon y. Now, if you are able to think of something, do you not think that, let's say for a while, to avoid confusion, let's say x by y as t. So can you not say that x by y square is going to be q square? This is going to be 4t, which when brought on the left hand side looks like this. Plus this is your 4 is equal to 0. In the next step, can I not say that I can write it like t square minus 2 into t plus 4 I'm writing as 2 square. All I'm doing is because I'm seeing it as an identity a square plus b square minus 2ab. Even if you don't know this, if this does not strike you, you can use your quadratic formula, splitting the middle term method, the Sridhar Acharya formula, the quadratic formula which you all remember. Through that also you can crack it quite easily. So with that, if I proceed further now, what I'll get is I can write it as a minus b whole square. So it is going to be 0. Square of any number is 0 only when the number is 0, which means t minus 2 is 0, which means t is 2. By the way, t is not 2, it is x upon y, which is going to be 2. That's exactly what we were asked. We were asked x upon y, x is to y, which is 2, which means 2 is to 1. And that's brilliant part. The answer is again going to be option A. So I hope you all are realizing the questions are pretty simple. All you need to do is pay attention, think of something, and a way will definitely be worked out if you know the nuances. Let's focus on the next question for the day, students. I hope you all are able to understand everything easily, comfortably, and things are running smoothly. With that, let us look at this next question for the day. I'll be really happy if some of you could answer this question. So do give it a try, attempt it, take your time, and write your answers in the chat box. With that, simultaneously, I'll also keep solving it. Now, what does it say? The time taken by A and B to reach their office from home is in the ratio 7:10. So please understand, let's say time taken by A and time taken by B. So time taken by A and time taken by B is in the ratio 7:10, which means time taken by A can be taken as 7x, time taken by B can be taken as 10x. I hope you all are realizing it. Along with that, we are told one more thing, that if B takes 18 minutes more than A to reach the office. Now, look at this, how easy this question is. B takes 18 minutes more than A to reach the office, which means B takes more time than A, and how much more time than B takes than A is 18 minutes. So shall I say, technically they are trying to say is 10x minus 7x is going to be 18, which means 3x is going to be 18, which means x is going to be 6. And when you say that x is going to be 6, what I can also say is that the time taken by each of them to reach the office. So 7x means what? 7 into 6, which is 42 minutes. Here, 10 into x, which is 10 into 6, which is 60 minutes. And I hope you all can see 60 minus 42 is 18, which is obviously going to happen. So I hope you all are able to understand this quite easily, that this is how easy these questions are. So 42 and 60, that's a brilliant part. And I hope the other students have also understood it quite easily. There is one more method, students. I am not saying that this is an additional method. This is just one of the ways of looking at it. How I see it, see. So we have time taken by A and time taken by B in the ratio 7:10. So I say time taken by A is 7, time taken by B is 8, but this is happening on ratios. However, actually, I don't know what is the time taken by them. But what I know is that time taken by B is, I'm really sorry, this is not 8. I have written it mistakenly as 8. This was actually 10. So what I know from here is that time taken by B is 18 more than time taken by A. But on ratios, this is 10 minus 7, which is 3. But in reality, it is 18 minutes. So the method which I'm recommending or prescribing here is that 18 is 6 times of 3. This 6 is called the multiplying factor. Multiplying factor means the actual value is divided by its corresponding ratio value. So the actual value was 18, its corresponding ratio value was 3. So 18 by 3 gave you 6. Now this 6 is that multiplying factor. Now I hope you remember 7 into 6 gives you 42 minutes here for A, and 10 into 6 gives you 60 minutes for B. Archie, the PDF of the session will be provided to you. The link is already there in the description of the chat box. So if you request there, they'll definitely provide you. So you can click on the link given in the chat box. They'll add your contact number to their respective WhatsApp groups, and there you will be receiving all the notes, PDFs, and everything. And I'm sure that you all are understanding that these sessions which we are conducting here live are just teasers of what we do in our classes. So both online and classroom offline batches are going to get started on 24th, 26th, and 31st of March for Nata and JE2. These are called crash batches. And if you need any clarity or require any information, you can always contact us on this given number. So yes, there is link already provided to you, Archie. I believe you can click on that link and you can contact us, and the PDF of this session will definitely be provided to you for free. Now, with that, I believe I can focus on the next question for the day, and whatever we have discussed so far is very easily understood by everyone. With that, can you all solve this question, students? Try to give it a try, everyone, and then we shall be discussing its solution together. How do I do this? It says that I need to divide rupees 117 among A, B, and C such that A share upon 2 is equal to B share upon 3 is equal to C share upon 4. I'll just look at these two first of all to make you understand what I'm trying to do here. So A share upon 2 is equal to B share upon 3. Can I not say that A upon B is basically 2:3? So the one of the methods would be that let's say A share is 2x and B share is 3x. Similarly, if I now look at these two parts, so what I know is B share upon 3 is equal to C share upon 4. Which will give you that B upon C is 3:4, which means if B is getting 3x, C is supposed to get 4x. I am told that this amount is actually 117 rupees. So shall I say the amount which is getting distributed among A, B, and C is going to be A's share, which is 2x, B's share, which is 3x, and C's share, which is 4x, is nothing but how much? 117. What I know from here is that's good path. That's brilliant. Session is lagging again and again. Okay, so is it happening with everyone? The comment which is made by Archie, she's saying that session is lagging behind. Is this issue being faced by everyone? Other students, kindly respond. And if it is not, I'll continue with the part or I'll get it fixed. So give me a response quickly, all the participants. I'm asking a simple question. Are you facing any issue, network issues with the session? Quickly respond. Okay, so just give me a second, everyone. So let's resume with this part, students here. What I'm trying to convey here is a very simple part. Just give me a second. I'm just fixing this issue. You need to stay here. I'll get this issue fixed in a while. Stay here, everyone. I hope now it is working fine. It is not lagging behind. Okay, Path. Okay, Archie. Thank you so much. So just give me a confirmation quickly. I hope we are running smoothly now. The session is not fluctuating anymore. So give me a response quickly. I hope it is working fine now. Everything? Okay, that's brilliant. Now let's focus on this part. So 2x plus 3x plus 4x was 117. So 2 plus 3 is 5. 5 plus 4 is 9. So what I know is that 9x is 117. Can we divide 117 by 9? So that gives you 1 and then the remainder is 2. That is 3. So x turns out to be as 13. Now when you get x as 13, what you can clearly see is you can very clearly crack the shares of A, B, and C. Give me a quick response, students. Are you still facing this lagging issue? I hope it is resolved now. The session is running smoothly, I believe. Give me a response. Is it running smoothly, students? Write a proper comment in the chat box. Now let's focus on this part, students here. So A's part was 2x, that is 13 into 2, which is 26. I hope you can see this very clearly. B's part was 13 into 3, which is 39. And C's part is 13 into 4, which is going to be 52. That's brilliant, Jatin. So I hope everyone has gotten this as the answer. This is A share, this is B share, and this is C share. So I hope we can continue further. The session is running smoothly now, I believe. Let us focus on the next question of the day. I hope this part you all have already heard of, so I can resume with the next question here. There comes the next question of the day. But before I discuss the next question, I'd like to discuss the same question with a different method because I want you all to have a short or a standard technique of solving this category of questions. So whenever you see A upon something, B upon something, and C upon something is equal, then I can always say that A is to B is to C can be 2 is to 3 is to 4. You can always conclude this. Now again, this is all given to me on which scale? This is all given to me on ratio scale. What I also know is that the total of A, B, and C would be 2 plus 3, 5 plus 4, 9. But on the actual scale, the total was 117. So we all know that 117 is 13 times of 9. So 13 into 2 is 26. 13 into 3 is clearly 39. And 13 into 4 is 52. So this is how you could have done it. This is also one of the methods. So I believe you all have understood this method as well. Now let's focus on the next question for the day. So I am bringing or fetching the next question right there in front of you on the screen. Give it a try, participants. Let's focus on this question now. How do we solve this question? Let's say what am I told or given here is that A is to B is 3 is to 4. So I am writing it like this, that A is to B I'm given as 3 is to 4. And then B is to C I'm given as 5 is to 3. So B is to C I'm given as 5 is to 3. And A is to D is given as 2 is to 5. Okay, I'll talk about all of this later or this method later, but I'll try to tell you the standard method which you have been doing conventionally, since your school days. So what I'm told is that A upon B is 3 upon 4 and B upon C is here 5 is to 3. Now please understand, here B is 4 and here B is 5. So can I do something to make them equal? So what I do is I multiply 5 by 5 here and I multiply 4 by 4 here. By that, what I have is 5 into 3, which is 15, and 4 into 5, which is 20. By this, I have B as 5 into 4, 20 here, and 4 into 3, 12 C here. Now, what does it mean? It means that now I can say that A is to B is to C is going to be A here is treated as 15. B in both of the cases is treated as 20. So yes, I can bring them on a common scale now. And C here is treated as 12. So first of all, I am now able to crack the ratio relationship between A, B, and C. Now, let's talk about A and D. Now, what is the relation between A and D? So the A and D are related as 2:5. Let's talk about C. The same thing here. Here, what am I having as? So let's say I'm having A and C here. So here I am having A and C as 15:12. I repeat, 15:12. Now please pay attention. The last step will give you the final answer. Here I'm having A as 2. Here I'm having A as 15. Now how do I get rid of it? How can I make A same so that I can compare D and C, and so that I can finally establish a relationship between all A, B, C, and D? That's the concern I have. So what I'll do here is I'll multiply 15 here in the numerator and denominator, and I'll multiply 2 here in the numerator and denominator. When you do that, you get 15 into 2 as 30 and 15 into 5 as 75. The ratio is still intact, it is unaffected, but it will finally give you the final answer. Here, 15 into 2 will be 30 and 12 into 2 is 24, which means A is 30 in both of the cases. So if A is 30 in both of the cases, D is and C are, so D here is 75 in this case, and C here is 24 in this case. So what was I asked? I was asked the relationship between C and D. So the relationship between C and D is 24:75. So that gives you the final idea. However, there is a problem that 24 and 75 both are divisible by 3, I believe. So I'll simplify this with the help of 3. So 3 when divides 24 gives you, I think, 8. And 3 when divides 75 gives you 15. So that gives you the final answer, 8:15. So I hope the question was easy. The other method for solving this category of questions is a different one, which is an easier one. So I'll try to demonstrate that method as well. So give me a second, I'll repost to this question here. See, how does this method work? Which works? Which method which I'm trying to share now. So A is to B, I was given as 3:4, right? Then B is to C, we were given as 5:3. So let's try and establish a link here. So I know that B was the common entity there. So what I'll do is this 5 I'll multiply above and this 4 I'll multiply below. So here 5 into 3 will give you 15. 5 into 4 will give you 20, or you could have said 4 into 5, which also give you 20, and 4 into 3 will give you 12. Now that's the relationship between A, B, and C. So that's a little easier method. Now, I was given one more thing. I was given A is to D. So I was given A is to D as 2:5. So I was given A is to D as 2:5. So now again I scale it up. How do I scale it up? So previously the common entity was B. Now the common entity is A. So I'll multiply this 15 below and this 2 above. So how do I do that? So 2 into 15 is 30, or 15 into 2 is 30. Then 2 into 20 is 40, 2 into 12 is 24, and 15 into 5 is 75. So that's the final ratio relationship between A, B, C, and D. However, we were not asked this relationship between A, B, C, and D. We were asked just the relationship between C and D. So the relationship between C and D will be nothing but 24:75, which we have already worked out as 8:15. So I hope you all are able to understand this quite easily now, that how can you do this? How can you use this method instead of the previous method? With that, let me bring you the next question for the day so that you get more clarity on this kind of concept here. Let's focus on this question for the day. What does it say? It says the ratio of income and expenditure of Amit and Sumit are 5:8 and 11:10, which means the income of Amit and the income of Sumit are in the ratio 5:8, which means if Amit earns 5x, then Sumit earns 8x. I hope this part can be concluded quite easily. And I am told their expenses. So the expense of Amit is to expense of Sumit are in the ratio 11:10, which means I can say the expense of Amit can be assumed as 11y and the expense of Sumit can be assumed as 10y. I hope you are getting it very clearly. Now, what am I asked? If Amit and Sumit save 7,900 and 21,000 respectively. Now, how do you calculate saving? Out of income, if you subtract expense. So out of Amit's income, if I am subtracting Amit's expense, I'll be left with Amit's saving, which is 7,900. Similarly, out of Sumit's income, if I subtract Sumit's expense, which is 10y, I'll get to know Sumit's saving, which is 21,000. Now, I hope you know what to do further, how to solve this question. What am I asked? I am asked to evaluate their final income. So to know the income, I need to know the X. So I'll try to get rid of Y here. So now how do I eliminate Y? Simply, you can use either elimination method or substitution method to get rid of Y and finally evaluate X. Once you have evaluated X, you can simply multiply it by 5 to get the income of Amit, and to multiply it by 8, you'll get the income of Sumit. I hope the questions are simple, the questions are easy. And with that, I think you have gotten a lot of clarity. We have tried demonstrating you that what kind of questions are asked in Nata Aptitude Test, what are the short methods or techniques you can use to solve those questions quickly. But there are a lot of methods, a lot of techniques which you can apply, which you all are supposed to learn to optimize your score, to have a better rank. And those ranks, those scores can be attained through this course, which I firmly believe. So if you want to have more of it, if you want to know more of it, if you want to excel in your examination, you can join our classes, which are starting on 24th, 26th, and 31st of March. It's called a crash batch, which is offline as well as online, whichever suits you as per your preference or reference, you can join them. You can always contact us on the given number 8086 111 With that, I believe we can call it today here. Thank you so much, students. You have been a great audience.